Good evening to all my classmates and good evening, sir. My topic for today is eigenvalues and eigenvectors. By the way, I am Wenefredo Magana Jr., MSME, major in Design and Production Engineer. By definition from Google, eigenvalues each of a set of values of a parameter for which a differential equation has a non-zero solution under given condition. Any number such that a given matrix minus that number times the identity matrix a zero determinant. For the eigenvectors, vectors that has its direction unchanged or reversed by a given linear transformation. A vector which when operated on by a given operator gives a scalar multiple of itself. Eigenvalues and eigenvectors can solve system of linear differential equations, describe frequencies of vibration, separate modes of motion, distinguish states of energy. Eigenvectors and eigenvalues also solve for quantum physics. Defining eigenvalues and eigenvectors. Here are square n times n matrix A, where A equals to A sub 1, 1, A sub 1, 2 to A sub 1 n. The next row is A sub 2, 1, A sub 2, 2 to A sub 2 n. The third row is En 1, En 2, and An n. So this is a matrix for ordinary matrix. Defining eigenvalues and eigenvectors. In eigenvalues, this is the formula. Ax equals to lambda x, where x is equal to eigenvector and lambda is equal to eigenvalue. Visualizing eigenvectors and eigenvalues. In this, we have a graph of a straight line. Imagine a linear transformation that stretches or compresses the underlying space. Most vectors change both their magnitude and direction. But however, eigenvectors are unique. They only change their magnitude but stay on their original line. For example, in a shear mapping, only one or two specific directions remain fixed or simply scaled. The eigenvalue lambda tells you the ratio of the vector's length after the transformation to its length. So in this, we see the graph. Uh, it's a straight line. Pero kung it's diagonal, so it remains in a straight line like this. Let's go to solving eigenvalues and eigenvectors. This is a formula Ex minus lambda Ix equals 0. We insert the identity matrix I just like multiplying by 1, factor out, then factor out the vector A minus lambda I close parenthesis X equals 0. Let's go to example, two-dimensional matrix. Find the eigenvalues and eigenvectors of matrix A, where A equals to 1, 1, negative 2, 4. Taking the determinant to find characteristic polynomial A. We summarize the computation approach for determining eigenpairs, lambda and X, as a two-step procedure. Step 1. To find the eigenvalues of A, compute the roots of a characteristic equation, determinant A minus lambda I subscript n equals 0. Step 2. To find an eigenvector corresponding to an eigenvalue lambda, compute a non-trivial solution to the homogeneous linear system A minus lambda I n equals 0. Let's take the example. Find the eigenvalues of A, 1, 1, negative 2, 4. So the determinant A minus lambda I 2 equals 1, 1, negative 2, 4. So we minus the lambda diagonally like in this example. So from the original vectors, it will be 1 minus lambda, 1, negative 1, 4 minus lambda. By multiplying in the matrix, 1 minus lambda times 4 minus lambda, then minus negative 1 times 1. So we get 1 lambda minus lambda times 4 minus lambda plus 2 equals 0. By multiplying, determinant A lambda I 2 equals lambda 2 minus 5 lambda plus 2 equals 0. In our basic algebra, by factoring, we get lambda minus 3 times lambda minus 2 equals 0. So the eigenvalues are the following. Lambda equals 3 for this, and lambda equals 2 for this. Then for step 2, to find corresponding eigenvectors, A minus lambda I n times x equals 0. For lambda 3, by substitution, so this is our original matrix minus the lambda. So we substitute 3. So it will be 1 minus 3, 1, negative 2, 4 minus 2, 3. So we simplify, it will become negative 2, 1, negative 2, 1. By elimination, we eliminate row 2. For column 1, subtract row 1 to row 2 equals, so negative 2 minus row 1 is negative 2. So it will become 0. For column 2, subtract R1 to R2 equals 1 minus 1. So our new matrix is negative 2, 1, 0, 0. This is so-called row reduced echelon form. Let's compute now for eigenvector, writing x as x1, x2. So this is our row reduced echelon form. So negative 2 times x1 and then 1 times x2 equals 0. By doing matrix multiplication, we get this. So let x1 equals 1. By substitution, we get negative 2 times 1 plus x2 equals 0. So we get x2 transpose x2 equals 2. So our eigenvectors for this eigenvalues lambda 3 are 1 and 2. For the next substitution of lambda 2, lambda equals 2. So this is the original. So we substitute negative 2 lambda 2. 1 minus 2, 1, negative 2, 4 minus 2. Simplify, negative 1, 1, negative 2, 2. By elimination, we eliminate the second row. For C1, subtract column 1, subtract 2 R1 to row 2. It will become negative 2 minus 2 times negative 1 equals 0. For column 2, subtract 2R1 to row 2 equals 2 minus 2 times 1. So it will get 0. So our row reduced echelon form is negative 1, 1, 0, 0. Let's compute for eigenvector, writing x as x1, x2. Negative x1 times 1, so we got negative x1. 1 times x2, we get x2 equate to 0. Let x1 equals 1. It will, by substitution, negative 1 times 1 plus x2 equals 0. By solving, we get x2 equals 1. So our eigenvectors for this eigenvalues, lambda equals to are 1 and 1. So in 2 by 2 matrix, it's easy to compute for eigenvalues and eigenvectors. Next, we move to 3-dimensional matrix. I'll choose the simple one so that madali lang matapos yung natin example. The eigenvectors of matrix A. A equals to 1, 0, 0, 3, negative 2, 0, 2, 3, 4. So find the eigenvalues. Balik tayo sa ating natutunan. So in diagonal, we deduct lambda. So determinant A minus lambda I subscript 3 pala to. 3 dapat to. Equals 1 minus lambda 0, 0. 3 minus 2 lambda 0. 2, 3, 4 minus lambda. By cofactor, so by cofactor, I choose row 1. So ito 1 minus lambda times negative 2 minus lambda times 4 minus lambda minus 3 times 0. Then minus the next is 0. Number multiplied by 0 is equal to 0, and then plus 0. So the simplify answer is 1 minus lambda bracket close parenthesis open parenthesis negative 2 minus lambda close parenthesis open parenthesis 4 minus lambda close parenthesis minus 3 times 0 minus 0 plus 0 equals 0. We simplify it. It equals 1 minus lambda 2 negative 2 minus lambda 4 minus lambda equals 0. We can solve now for eigenvalues. Lambda is equal to 1. Lambda is equal to negative 2. Lambda is equal to 4. Next, we solve for eigenvectors. By substitution for lambda 1, this is our original matrix. And this the matrix minus the lambda diagonally. 1 minus 1, 0, 0. 3 minus 2 minus 1, 0, 2, 3, 4 minus 1. We simplify it. So row 1, 0, 0, 0. Row 2, 3, negative 3, 0. Row 3, 2, 3, 3. Let's compute for eigenvectors, writing as x as x1, x2, x3. So this is our row reduced echelon form. 0 times 0 x1, so 0. 0 x2, 0 pa rin. So we can't determine the x1 here. So in row 2, 3 times x1 minus 3 times x2 plus 0 equals 0. So wala na x3. So let x1 equals to 1. So by substitution, 3 times 1 minus 3x2 equals 1. So we get 4x2 equals 1. So in row 3, 2x1 3x2, 3x3. We know that x1 is equal to x2 equals 1. So we substitute 2 times 1 plus 3 times 1 plus 3x3 equals 0. So the answer is x3 equals 5 thirds. Eigenvectors for the eigenvalues lambda 1 are 1, 1, 5 thirds. Next is for lambda negative 2. So again, in our original matrix, we minus diagonally the lambda. 1 minus negative 2, 0, 0. 3 minus 2 minus negative 2, 0. 2, 3, 4 minus negative 2. We simplify, makes 3, 0, 0, 3, 0, 0, 2, 3, 6. So let's compute for eigenvectors. Writing x as x1, x2, x3. So in row 1, so it will become x equals to 0. Then row 2, ito ay hindi pa pala to na kasi walang x2 rin dito. So x1 din ang makukuha natin. So dito is sa row 3, 2x1 plus 3x2 plus 6x3 equals 0. So let x3 equals 1. Then substitute 2 times 0 plus 3x2 plus 6 times 1 equals 0. x2 will become negative 2. Our eigenvectors for these eigenvalues lambda equals negative 2 are 0, negative 2, and 1. And for the last eigenvalues for substitution lambda equals 4. So this is our original matrix again. So we minus diagonally. 1 minus 4, 0, 0. 3 minus 2 minus 4, 0. 2, 3, 4 minus 4. So we simplify. We get negative 3, 0, 0. 3, negative 6, 0. 2, 3, 0. So iba din yung formation niya kasi yung column 3 is all 0. So let's simplify it. So let's compute for eigenvectors, writing x as x1, x2, x3. By doing matrix multiplication, we know that x1 is equal to 0. For the second row, x3, x1 minus 6x2 equals 0. So we know that x1 is 0, so we substitute 3 times 0 minus 6x2 equals 0. I divide by 6, x2 equals 0. For row 3, 2x1 plus 3x2 equals 0. We know that the values of x1 is 0, the x2 is 0, so we substitute 2 times 0 plus 3 times 0 equals 0. For x3, we have no information, so x3 makes a free variable. Let's say x3 equals 1. So our eigenvectors for these eigenvalues are lambda equals 4, are 0, 0, 1. That's all for my report for eigenvalues and eigenvectors. Thank you for listening. That's all.